Welcome to section 3.2, Graphing Linear Equations. So before we can get down to any graphing part, we're going to go work on some basic foundation. So let's start with this example, our first example, y equals 3x plus 3. So what I would like you to do is identify your slope. Slope is always the number that's in front of x, so my 3. Now, if you are given a whole number, what I need you to do is you're going to convert it to a fraction. So if it's a whole number, I want you to put it over 1. Now, since this is a positive slope, if it's positive, then your numerator will tell you to go up, and then your denominator will tell you to go right. If it was negative, then simply your top number will go down, but on the denominator, you still go to the right, always. So again, if it's positive, you go up with your numerator. If it's negative, you go down with your numerator. But both cases, whether if it's positive or negative, your denominator will always go to the right. Once you identify your directions, in the event you don't have any room for graphing, so if you have no room on the top or no room on the bottom for graphing, then simply do the opposite of what you have found. So after you find your direction, then you can do the opposite when you have no room to graph on the top or on the bottom. After you identify your slope, next you're going to identify your y-intercept, which is this number here, the number that's by itself, no variable, so R3. I want you to put in coordinate point form, so x comma y. Your y-intercept, your x is always 0, and the y is a number that's by itself, in this case 3. So my y-intercept is 0, 3. Now once you finish identifying slope and y-intercept, then we're going to start on finding coordinate points for our graph. Now the reason we're doing coordinate points is because what I've seen in the past experience, I've seen some graphs that were off and points were taken off. So if you want to get partial credit or you want to get full credit, first thing is identify slope, y-intercept, and then finding 3 coordinate points that will help you graph well. So we're going to do my x, y table. Now, given any type of linear equation, the 3 x values that you can use. So what I would use is 0. It never hurt to use 0 in the middle. And then 1 from the left side, which is -1. And then 1 from the right side, which is +1. Now, be very careful on what type of x values you can use, and here's why. I can use this x value because in our linear equation we have whole numbers. If your slope and your y-intercept start off as whole numbers, then you're okay to use these type of x values. The ones you have to watch out are the fractions, so you have to be very careful with fractions. We're going to have some example with fraction, and I will work out and show you how to work with slopes that start off with fractions. But let's continue with this example. So now I don't have to do anything with the 0 because we already actually have a coordinate point where x is 0 and the y value is 3. So I'm going to write 3 here. What I'm actually going to do is use -1 and 1. So I'm going to do actually work for both of them. So y equals 3 times, so for -1, I'm going to plug into x and then bring the +3. So I'm going to simplify 3 times -1, which will be 3, -3, and then bring down the +3. -3 plus 3 will be 0. So my y value when x is -1 is 0. Now I'm going to do the other one. 3 for x, I'm going to plug into 1 and then bring the plus 3 out. Simplify 3 times 1, which will be 3. Bring down the plus 3. So 3 plus 3 will be 6. So my y value will be 6. So once you get your 3 corner points, -1, 0, 0, 3, and then 1, 6, you're simply just going to plot on a graph, connect the 3 dots together to make your perfect graph, and that's pretty much it. So, to review, identify slope, y-intercept, create your xy table. Now you can use these type of x values if your linear equations start off with whole numbers. If you're going to have fractions, you're going to be using different x values. But this is what I expect to see on the test in order for you to get full credit or partial credit if the graph was not correct.